Hello everyone, and welcome to today's webinar from Midas. Before we start, I'd just like to mention, if you do have any problems or any comments, please feel free to raise your hand or post comments in the comments tab. My colleagues are available to help with any problems, whether it's an audio or video problem, or you have any questions related to the presentation itself. And today, the topic will be the new highway assessment code, the CS454, the loadings and assessment procedures, and the implementation of those in the upcoming new release of Midas Civil. So, in terms of contents, there are 4 key areas that we're going to go over. First, we're going to have a quick introduction of the CS454 and the changes that it brings to our procedures. Then we'll discuss the Midas Civil 2020 version 2.1 release notes overview. We're going to skim quickly through some of the functions and focus on the highway assessment features. Then we're going to talk in a bit more detail about the implementation of the All Model2 in Midas Civil, and we're going to finish with a highway assessment of a pre-stressed concrete bridge with low rating results. So, starting with a brief overview of the new code. I'm not going to dwell too much on it. I'm just going to highlight a few of the items that are relevant for today's discussion and how these have been brought into Midas to be available for the engineers to use. So the code itself, it was released last year around middle of the year. And basically, the code supersedes the previous BD21, BA16, and BD37. And in that sense, what it does is it essentially brings the assessment process and loading in one place instead of having to go to different codes for those. It also introduces a bit of refinement of the traffic loads so that they reflect better the current highway regulations, and it also brings other loads into the same code, i.e. in the CS454 it directly provides information on how we can address temperature, wind, abnormal vehicles as HB, and so on, which previously were in other codes, not in the assessment code BD21. A couple of keynotes that are worth mentioning though. Special vehicles remain in BD86, so those are not brought in. We still need to refer to that code if we are dealing with any of those. And the code itself, so the new code CS454, references other codes for the specific material checks, for the specific materials in terms of member checks and the resistance of our elements. In general, the assessment verification itself remains as it was. We have the resistance bigger or equal than the assessment action effects. Pretty much no changes here. Again, we have our assessment resistance being a function of our section through different factors applied. And again, we have the condition factor. In terms of the assessment action effects, exactly as it was, no differences from the BD21. We have our loads, so then we apply our partial factors for the loads and for the effects, and that gives us our assessment action effects. So no surprises in that area. In terms of traffic loading, this is where the new code CS454 brings a couple of changes. So in the new code, the characteristic traffic action, we have 2 different models that we can use compared to BD21 where we had the type HA loading. So in the new codes, the new load models, we have the AOL Model 1 and AOL Model 2. The AOL Model 1 is a new type of vehicle or a new type of traffic load model that represents real vehicles from the current highway regulations, and it essentially is a single vehicle or a convoy of vehicles. And that load model is suitable for all types of structures. as per the code. The AOL Model 2 is essentially the UDO and knife edge loads that are based on the type HA from v2.1. So that is the one we are very familiar with, but there are a couple of key items to mention. In CS454, there are a few new considerations in relation to loaded length and how that reduces the intensity of the loads. And additionally, the new code identifies that this load model is not suitable for certain situations. And I'm not going to go into detail of those. You can check the code for it. But essentially, the load model is not fully applicable in every scenario. However, overall, in most situations, either of the two models can be used. So the code does not tell us that we don't have to check both cases, so AOL Model 1 and AOL Model 2, and then take the worst of the two. We can do our assessments, we can carry them out using either of the two models, bar the situations where AOL Model 2 is not applicable. And in terms of abnormal vehicles, as we mentioned previously, these are still in BD86. The new code references it and says that in situations where those special vehicles need to be considered, we need to refer to BD86. So in terms of Midas Civil and the upcoming release, so these are the contents of the contents of the release note, which will come together with the release and highlights the new functions that are implemented or introduced into the program. And within this, we will notice the number 9, the British Standards assessment based on CS454. So if I can briefly mention a few items. So in those release notes, we're going to find a couple of pages which will highlight some of the key features around the new functions around CS454. But in short, these are basically the moving load vehicles where we are implementing the AOL Model 2, and we are also introducing automated pre-stressed concrete bridge rating. So let me look in a little bit more detail on those two. So the AOL Model 2, that is the UDO and knife edge load. So we're introducing we're bringing into the software a standard vehicle available directly to select with the definition as per the new code, so that this can be used for current or future assessment projects. That vehicle, what it basically consists of is it brings the intensity loads as per the new code, and it brings in the option to specify the traffic flow and the surface categories in order for the software to correctly apply the K factors in the analysis. So if I can briefly jump into Midas Civil, just so that I can show you how these functions are brought in and that you're familiar with the interface. So for the demonstration today, I have a preset model, a predefined model that is a 3-span precast composite girders with 2 abutments and 2 intermediate supports. Nothing too special. We're not going to go into the details of modeling this. There are plenty of other tutorials and videos that you can go to. We're not going to waste time on any of that, and we're going to focus just on the functions related to the new features with CS454 that we want to cover. In this model, just for a little bit of background, as I said, I have modeled everything in. We have a few construction stages introduced to simulate the construction sequence. I've already defined all the loads, section properties, materials, etc., etc. And I have also introduced the 2 traffic lanes. So in our model, we have 2 lanes in that we're going to use for the vehicles and moving load cases. So the AOL Model 2, that is, if we want to use this, it is as we're used to under loads, moving loads, under British standards moving load code, and then if we choose vehicles and add a new standard vehicle, now under the standard name we can choose also the CS454 in parallel to the other standards which were available previously. Under this, then we will be able to select the ALL Model 2. At the moment, that will be the only one available. As I mentioned, we're not introducing the ALL Model 1 yet. I will speak about this in a second. For this, we can choose the lane factors, whether we want to apply them directly as per the code, or we want user-defined values, so we can control these if we want to. Here we have a table with the definition of the load intensity as per the code. And as I mentioned, at the bottom we have the specification for the traffic surfaces and the load level, so the traffic flow, the surface category and the traffic flow, in order for the software to be able to apply the right factors. And that's pretty much all. We simply press OK, and we have the model defined in our model. I'm going to add one more special vehicle just for the demonstration. So BD86, let's say we're going to add a special vehicle 150. This is as it has always been, so we're not going to go on the details around this one. Once we have the two vehicles, and as I mentioned, I already have two lanes predefined in the model, we're going to put those two vehicles in a moving load case so that we can analyze them and check some of the results. So the moving load case, let's say I'm going to define one ULS one load case that I'm going to use in my ULS combinations. Here now, a change in the interface is that we have the new code available. So when we select the load models which we want to be available for this load case, if we choose CS454, that will give us the ALL Model 2 and the SV150 available. If we had more models defined, then those would be available, but in this case, we have a very simple situation for the purpose of this demonstration, where we have just one for each. In the auto live load combination, for the right load application, we need to have that checked on, and then we need to also specify the ultimate limit state. The limit state that we're working for with this moving load and the combination. I'll come back to these in a second to explain them in what they refer to. And at the bottom we have the lanes definition, so our two lanes, we want to include those in our selected lanes, and these two we also want to say let's consider straddling of the vehicle between the two lanes. For the combination factors, the idea behind this is when we include the auto live load combinations, what the program does is it automatically applies the partial load factors for the combinations of the All model and the special vehicle. The reason this is needed and why we do it here in our moving load case instead of later on in any load combinations is because the partial factors themselves affect the optimization and the vehicle position for the most critical effect, simply because the two vehicles are not applied and don't have the same partial factor applied to each of them. And that can bring one critical situation without partial factors to be not critical anymore once we apply the partial factors. So essentially the whole optimization needs to be carried out with the final loads so that we get the right position. And so we apply them in the moving load case, and we have to set what condition this moving load case is going to be used for. And so I can apply this moving load case, and I can do another copy of it, which is SLS1, just to complement this one, which will be the same, but let's say it's going to be the serviceability limit state. And press OK. And with these two moving load cases defined, I can run my analysis and then check some results and look into the look into the bridge rating at the end. So press run, and while this is running, as long as it starts, we're going to go back to our presentation. It should be fine. It should take a few minutes. There we go. It should be a couple of minutes to analyze, but not to waste time. Well, let's go back to the presentation and look into the other part of the analysis, the other part of today's presentation, which is the bridge assessment. So for the bridge assessment itself, very briefly, basically it stays as it used to be. No new features here, as we mentioned. When we're dealing with the bridge rating, we're interested in a few key parameters that we need to check. First, we need to make sure we need to show an assessment verification demonstrating that the assessment resistance is higher than the assessment load effects. Additionally to that, usually we're looking to provide a structural adequacy factor, the resistance and the assessment resistance divided by the assessment effects, and this gives us basically our safety factor, an indication of where we are on the utilization. And if we're dealing with a scenario where we need to consider special vehicles and BD86, then we are usually also providing reserve factors. These are in a similar way capacity over applied effects, but unlike the structural adequacy where it's full capacity over full applied load, for the reserve factors, these refer specifically to the safety factor on the special vehicle itself, or on the special vehicle itself. And these factors have two different options. The first one, the upper one here, is the reserve factor with accompanying standard traffic load, in which case we also have the effect of the standard traffic, or if that reserve factor comes out to be critical, we could look into a reserve factor without associated standard load, which could be implemented if necessary with additional traffic management measures. The difference of these reserve factors, however, as I mentioned, is against the structural adequacy, is the effect from the special vehicle is put against the available resistance. So instead of using the full resistance, we subtract what is utilized by the permanent load, by dead loads and super dead loads, and we also take away the resistance from associated standard loads if there are such on the structure, which basically gives us the available resistance, or what is left over from these initial effects, and then we divide that by the effects from the special vehicle alone, from the special vehicle itself, in order to get a safety factor, a reserve factor that is the safety of on the special vehicle. So how is this implemented in Midas? We have the PSC bridge rating according to CS454. This is all brought into under the rating tab. So far, this tab was mostly targeted at the AASHTO, so the United States region or the American standard codes, but now we are implementing the CS454 as well. So the assessment is under the PSC bridge. So at this stage, we are bringing in the automated assessment checks for the precast for the pre-stressed concrete bridge, whether it's a box section or a precast composite, both will be available. And what this will allow us to do is, by providing some design condition input, the software will automatically produce those results that we're interested in for the assessment, In terms of, we'll be able to obtain a member design report, which is a full detailed member check for that resistance verification. We also have a bridge rating result tables, so all those adequacy checks and the reserve factors are automatically calculated and presented to us. And we also get a bridge rating summary report, which is a short summary of the findings of the reserve factors and the adequacy of the structure. So with this, let's jump back into Midas Civil, see if our analysis is complete. There we go, yep. And see how we can perform those assessment checks. Very briefly before we move on to that, in terms of the results, so as it was before with the v2.1, again we can check our results. Just to demonstrate a couple, the moving load tracer for our ULS case, we can choose a one of our beams and check the vehicle position and distribution for that. In this case, for example, I've hit one where the critical position is the special vehicle in between the two lanes. If we choose another lane, another element maybe, there we go, we can find also positions where the two vehicles are next to each other in the two lanes. So the full interaction is implemented obviously as per the PD86. This is the one still driving how the two vehicles should be applied, and that is with the exclusion zones in front and after the vehicle, and when straddling, pushing from one lane into the other, and so on. But this is as per the standard moving load behavior and analysis in Midas, so we're all familiar with that, and you can find plenty of information if necessary. Now, in relation to back to the rating, as we mentioned, under the rating tab, we can now introduce our assessment checks for CS454. So under rating, under PSC bridge, here we can choose the code that we want to work with. In our case, that is CS454. And then there are a few parameters that we can define and look into in order to make the software perform the checks for us. So let's go through this menu, the functions in this menu one by one, and see what is there for us to define. So the first one, design code assessment, is simply the design code itself. So that is, if we've already specified the correct code from the drop down above in the ribbon menu, then we don't need to do anything here. From the second one, which is assessment code parameters, this brings up the parameters for the assessment. So we can use either characteristic strength or worst credible strength. Both are supported in the program as they are specified by the code. We can choose which one we want to work with, and that affects the factors that are used. If we set on user input, we can modify the design parameters. So those partial safety factors are available for us to modify if necessary, but by default they will be as set by the code. Further down in the menu here, we can choose which checks we want to perform for the different limit states. At the moment, the available checks for the strength limit state will be flexure, shear, and torsion. And for the serviceability limit states, that would be stress crack check. And furthermore, we can choose which of the limit states we want to include in the report, i.e. we can choose to print out only the ultimate limit state or only the serviceability limit state. Under the menu, the next function is modify concrete material. This is a menu that is the same as what we're used to in the composite pre-stress design that we have under the PSC tab. We basically need to specify the parameters, the materials that our members are built with. so that the software knows what yield and strength parameters to use for the design. We have the two halves, the girder, so the precast girder, concrete material and rebar material, and the slab on top in this case, again, concrete and rebar material. If these are not standard, in this example, we've actually left them as modern Eurocode materials. But if these are something different, we can simply switch off the code and specify the strength of the materials manually, so that we can adjust for any type of historic materials that we're working with. I'll leave this to the code as it was for the purpose of this example and move on to the next item. Finally, the last type of parameters that we need to provide is the load combinations for assessment. So you will notice that these load combinations we're defining them separately compared to the ones under results load combinations. The reason for this is because of the slightly different types of checks that we're performing, the type of parameters, the type of factors that we need to introduce, and because originally in the development here, as the code specifies, we need to separate the moving load cases as an independent load case for us to be able to obtain those reserve factors and the adequacy of the structure. And so for this reason, the assessment procedure has its own assessment cases to be defined independently from the general results. So for this, let's define a couple here. Let's say this will be ULS1. We can choose the limit state. This is ULS or SLS, depending on what type of checks we want to use this combination for. Then we choose the combination type. This refers to combinations 1 to 4 as set out by the standard. These are, we can find them in the CS454, I believe Appendix A was where they were given. Gamma F3, so the partial factor for ULS, this is usually 1.1, so set that up. And then on the right-hand side, we can put in the load cases that need to be considered inside this combination. So in this case, we'll keep it simple. I'm going to include the dead loads, the secondary effects from the constriction sequence, so tendon, creep, and shrinkage. And on top of this, we're going to add the super dead load from the post processor, from the post installation. The dead loads themselves factor should be around 1.15, I think, if I remember correctly. Secondary effects are usually taken with factor of 1. Super dead loads, depending on what we're referring to, I think this was 1.2 or 1.75, but let's say conservatively I'll take that as 1.75, assuming this is the surfacing in that load case. And then finally, at the bottom right corner, this is where we need to include our moving load cases. There are two options here, either special vehicle, where we can include pretty much any load case that we've defined, whether it was an assessment load case or not, we'll be able to include it in, and then that will be part of the checks. But the one that we should be going for when we have correctly defined our assessment load cases is actually the combined vehicle, in which case we choose our ULS1, but the software then finds internally the assessment vehicles and the special vehicles and separates the results for them so that it correctly addresses that issue of providing the reserve factors. Note that here on the right hand side, the factor for these load cases is locked out. This is because, as I mentioned earlier when we were defining this load case, we've already included the partial load factors into the load case itself when applying the load. That was related to that auto live load combination and setting up ULS 1, combination 1 in the moving load case definition. So for that reason here, we need to include that load with a scale factor of 1 because we've already applied those factors. And with this, my combination is ready. I will quickly create one more for the purpose of the SLS. So in fact, I'll take the original one, copy it, and just rename that SLS1. Change this to SLS combination 1. Gamma factor will be 1.0. And then these factors here need to be modified. I will simply set 1 across. And we need to change to SLS1 for this load combination. Basically turning everything into a serviceability limit state. With this, we have 2 load combinations. Of course, we can have as many as we want, but for the purpose of this demonstration, to keep it short, we're gonna just go away with these 2. One for strength and one for serviceability. With this, if we go back to our bridge rating menu, we've basically specified all the parameters or all the general input that is needed for the purpose of the to comply with the code or the code requirements. And now the only 2 menus, the 2 inputs here left are the section for assessment check and section for assessment report. These are equivalent to what we're used to under the composite design functions that we have previously, either steel composite or concrete composite. Basically what this asks us to do is we need to set up for which elements and sections we want to run the checks. So if I choose a set of girders along my structure, let's say I'm going to take that primary here. Let me just see if that's, yes, that is my last span. So after the second pier to the end. And we're going to run the design checks for these elements, section I, which is basically every section across that girder. Further to this, here in the section for assessment checks, we also specify the class category. This is related to the serviceability checks and the limiting values for the stresses. Let's say I'm going to set this as class 2 for the purpose of this scenario. And having applied this, we can also set the sections for assessment report. So this one specifies for which elements we want to obtain the detailed calculation report. Let's say I'm going to take one element at the edge, at the end of the over the support, and one at midspan, and apply this as well. And with this, basically, all our definitions have been done. That's all we need to do, and we can run our assessment. Design results, yes, we want to delete them. That's probably left over from earlier when I was creating this model and testing it. So we'll lose those once we rerun the design checks. There we go, so a few seconds and the design checks have been performed, and with this we can look into some of the results. So under assessment result tables, for example, we can check the flexure reserve factors table. So for bending, we can choose, again, similar interface as usual, the elements which we want to include, which load cases and which locations. But that basically gives us a table with all the elements for which we perform the check, different sections, different load cases. The load cases check different conditions in terms of maximum axial, maximum shear, maximum bending, etc., etc. And for each one of those load cases or scenarios, the software evaluates the performance and the reserve factors. Here we can see, so RA star is the assessment resistance, Then we have the special vehicle contribution, the dead loads and super dead loads contribution. SST star is what we've used for standard vehicle contribution, referring to the new CS454 instead of the previous SHA star, which was referring specifically to the HA vehicle. SA star is the total load, so the full assessment effect. And then the three ratios, so A is the adequacy, simply the resistance over the applied effect. And then we have the two psi factors, checking the available resistance for the special vehicle. And in the end, it comes up with a summary check. So in the last column, we have an OK or not OK, or not good if the check has failed. Further to that, like in this example, the flexural capacities are all OK, but we have, for the purpose of this demonstration, I've actually left the shear to be failing. So if we check the shear capacities, the table is the same, so the same tables on top, but everything's highlighted in red because there is failure here and there. So for example, here the adequacy is quite low. So in both these tables, as usual in Midas, if a certain section passes, it's normal black line, but the ones that fail are highlighted in red, as we can see here. And that is generally useful for speeding up our processing of the data. Furthermore to this, what we can check is we can actually print the assessment report and check the detailed report for the assessment. That takes about 30 seconds, so instead of spending that time, I'm actually going to open that report, which I've prepared in advance, and we can have a look at it. So in this report, what we get is a summary tab in the front, which includes all the sections that we have included in our design checks, and a worst case scenario summary of the worst rating that we've obtained for the different checks. Further to that, we have an assessment summary, which includes the design conditions, an introduction to the assessment factors and how they are calculated, and then a flexure reserve factor, shear reserve factor, and so on, based on element by element. So here you will see this is our element 17 and then element 110. So this is a summary for the specific element, showing the different cases and reserve factors for the individual load combinations of that element. And furthermore, the last item that we get is, again, for each one of the sections that we have run the checks for, we get the detailed calculation report. This is very similar to the other composite design calculations that we have, like the PSC composite design, for example. At the top, we have design conditions and design inputs, giving us section properties, partial safety factors, material properties that have been considered, pre-stressed steel, etc., etc. So all the inputs that we're starting with in terms of defining our section. And then the software moves on to the actual design checks. So in this case, flexural design checks for the section. We have the analysis of the section in terms of obtaining the resistance of the section based on the rebar and tendons in the girder. That gives us our ultimate resistance, and then we check against the code, which tells us we need to satisfy this condition, and our resistance 590 against the applied load, the assessment effect 329, therefore okay. And then the shear check in a very similar manner. All of these checks, as per the code, detailed equations, results, parameters used in every equation, reference to the code where it comes from. So a full detailed calculation report telling us in the end whether our sections are okay or not okay for each individual check. And all these are automatically available as we just demonstrated, so that we can include them in our assessment reports. And with this, I've pretty much covered the items that we were targeting to highlight today, referring to the new functions related to the highway assessment code. With this, I'll bring this presentation to an end. Hopefully it was useful, and it managed to highlight some of the upcoming features in the release, in the next release of the program. If you do have any questions, please post them in the comment section. We'll leave this session open for a few more, for a few more minutes, and we'll take those away. Anything that hasn't been answered, we'll follow back and come back to you via email. Thanks for your attention, and enjoy the rest of the day.